You have 50 ounces of a 25% saline solution. How many ounces of a 10% saline solution should you add to make a new solution that is 15% saline? Anytime that we're mixing two things together to come up with a third, we can organize our given information using a 3x3 box. Generally speaking, we always want the third row to represent the overall mixture, and the first two rows to represent the two things that are being mixed together. And we're going to look for column headers that enable us to multiply the first two columns together to come up with the third column that is their product. When we're mixing liquids, those column headers are going to be percent times volume is equal to concentrate. So let's take a quick look as to why those are our column headers. Suppose we have a 25% saline solution, and the overall volume of the solution that we have is 10 ounces. How would we determine how much of the solution is salt and how much of it is water? Let's consider these to be our salt particles that are floating around here in our saline solution. And for the sake of this discussion, let's illustrate it as all being down here. The question is how many ounces are salt and how many ounces are water? If we have a 25% solution, what that means is that 0.25 or 25% of, and of means multiply, the overall volume of the solution, which is 10 ounces, and that gives us how many of the ounces are salt. So when we multiply this together, we would get 2.5 ounces of salt were added, and that means that the other 75% of the overall mixture was water. So to get a 25% saline solution, we added 2.5 ounces of salt to 7.5 ounces of water to get an overall 10 ounces of a 25% saline solution. So to recap here, if we want to determine how much salt is included in this saline mixture, we multiply the overall percentage of the mixture times the total volume, and that gives us how much salt is present, but more generally speaking, we'll call that concentrate. And we'll use this as our column headers anytime we're mixing two liquids together. So let's come back up here to our problem. Let's replace those generic row headers with a more descriptive row header because we know we're mixing a 25% solution with a 10% solution, and we want these row headers to be a little more descriptive. In the percent column, we're going to indicate our percentages converted to decimals. Our 25% solution will have a 0.25. Our 10% solution will have a 0.10 here, and the concentration of the mixture that we want is 15%, so 0.15 comes here. The question is asking us how many ounces of the 10% solution must be added. So the number of ounces of the 10% solution is our unknown quantity, and that's going to be what we want to assign the x to. So we're going to put x in the volume cell for the 10% saline solution. We were given the fact that we had 50 ounces of the 25% solution, and since we're combining these two quantities, we're going to add 50 plus x to get the overall volume, which will be 50 plus x. Now, as with many of our mixture problems, once we have two columns populated, this is when we want to multiply across to come up with the third column. In the first row, what we see is that we have 25% of, that means multiply, the 50 ounces that are present, 25% of those are the concentrate, which in this case is salt. So we have 12.5 ounces of salt present in that first solution. 10% of the ounces in the second solution are the concentrate, again being salt in this case. So we multiply these two together to determine how much of that concentrate is present, and it's 10% of the x ounces, or just 0.10x. In the third row, 15% of these number of ounces are salt, so we'll say 0.15 of however many ounces are present are going to be the concentrate. In order to come up with our linear equation that we solve, we're going to add down. We add the first two rows together to come up with the total, that is the third row. Essentially what we're saying is that if we add the 12.5 ounces from the first solution to this number of ounces from the second solution, we're going to get this number of ounces of salt in the overall mixture. So we're adding 12.5 plus 0.1x, or 10% of that volume, is going to be equal to 15% of the total volume in the overall mixture. Now we have a linear equation that we can solve for x. We start by simplifying both sides as much as possible, which means that we'll distribute the 0.15 into the parentheses over here on the right. 0.15 times 50 is 7.5 plus 0.15 times x. And on the left-hand side, we still have 12.5 plus 0.1x. To get our variable terms on one side, we're going to subtract 0.1x from both sides, which leaves us with 12.5 on the left and 7.5 plus 0.05x on the right. Then to get our constant terms on the left, we'll subtract 7.5 from both sides, which leaves us with 5 on the left and 0.05x on the right. To completely solve for x, we're going to divide both sides by 0.05, which is going to yield that x is equal to 100. 5 divided by 0.05 is 100, and our units are ounces. So the question was, how many ounces of 10% saline solution must be added? And our answer is that we needed to add 100 ounces of the 10% saline solution in order to generate the desired mixture.